Got some paper now, and you're copying down what you see on the board. I see some of you have already done that. How did you do that so fast? Well, if you can recreate that information, just put it on my desk there, that you see on the board from memory, you should do pretty well on our quiz and test on the metric system, because it's all about these prefixes. These 6 things. You got to know the prefix, you got to know the abbreviation, and you need to know the number that goes with the prefix. The last column, you might say, well, that's not important. Actually, I think the last column is the most important. Because when you think about why the metric system has been so hard for you, it's probably because you don't use it. It's not hard for you to understand what a liter or 2 liters is because you see it and you use it all the time. Many of you already know about a millimeter because when you get the lead for your pencil, it says the size, how many millimeters it is. So those are ones we use on a regular basis, maybe even kilometers. But it's the ones in the middle that you use less often that really throw people, okay? The metric system is so much easier. As I told you guys before, you don't have to deal with fractions in the metric system. And your math is so much easier. You can do the math in your head, and we're going to do that today. When you need to change from one kind of unit to another, it's super easy. Changing from millimeters to meters is a piece of cake. It can be done in your head. But if I ask you to change 3 inches, 3 7/8 inch into feet. How many feet is that? Point something, right? It's less than 1. And it might take you a little while to figure that out and calculate. If I ask you in the metric system, 3.2 centimeters, how many millimeters is that? Well, no? 3.2 centimeters, or how many millimeters? 32 is the correct answer. Now, for the rest of you that had no clue how they just came up with that answer, I'm going to show you. It is super easy. You need to relax. You can open mind, say, I can learn this stuff. Okay? One of the things that's helpful, most helpful, I think, is having an example. And that's why we did the metric dance yesterday. Because if you've actually done this, you've held it in your hand, you know what a millimeter looks like, you use it on a regular basis, you will remember it. But if it's just a word up there on the board, no way, you're going to forget it. So, you guys ready for the metric dance again? You're still copying down? Huh? Yeah, huh? You look a little bit? No? Okay. I know it seems stupid, guys, and I ask you to do some stupid things sometimes, but sometimes the stupid stuff you remember much better, and it's going to stick with you, okay? And I'll show you how you can use the metric dance here in a little bit. But let's start with Miller. Show me Miller. Show me cento. Show me decim. Show me meter. Good. All right. And then a decameter would be how big? The room. Hectometer. That's a new move in our dance. That means all the way to the fence. And kilometer. Gotta use 2 hands for that. That's way out there. That's Saguaro High School, right? Okay? So all we're doing with these prefixes, when we stick them in front of meter, is we're taking this measuring stick, this meter stick, and we're making it either longer or shorter. All the ones below there make it longer. This is not the right size measuring stick to measure the distance from here to the moon. If I used that, I would have a very big number. I could use it, but it's not practical. And this is not the right measuring stick to use to measure the thickness of your pencil lead. Okay? Because it's going to be a very small number. It's silly. So we take this and we make it bigger or smaller. And we use these prefixes not just with meters, but with liters and grams and degrees could use it with anything. It's not become real popular, but like the example I gave you yesterday. You could have a deca cookie, a hecto pizza. A hecto pizza would be 10, 100. Hecto 100. Be 100 pizzas. Or it could be a pizza that's 100 times bigger than a regular pizza. Okay? So they just make it bigger or smaller. You've worked with prefixes before. You use them in language arts all the time. They change the meaning of a word. Instead of a test, it's the pretest, which means you take it before. Instead of just a meter, it's a decimeter. It's this broken into how many pieces? 10. And how big is each piece? This big. Okay? If you have that image in your head, you'll find it's real easy to estimate and to figure out what the right answer is, particularly if you have like multiple choice questions. Let me show you what I mean. Tell me, how many of these, what are these called again? Decimeters. How many decimeters wide, that would be this direction, is your desk? You're going to have a question like that on one of the tests, and you're going to be sitting there doing this. So don't be embarrassed to do it now. How many? 7. I heard 6 or 7, okay? Now, somebody told me 10 last period. I said, no way is it 10. Because I happen to know that this is 10 decimeters. Is your desk that wide? No. 7, maybe. Okay, 7 hands wide, yeah, maybe. So how many of these to one of these? 10, okay? So if your desk is 7 decimeters wide, can you tell me how many meters wide it is? 0.7. Can you tell me how many centimeters wide it is? No. 70. Can you tell me how many millimeters wide it is? 700. Again, some of you are starting to catch on. They're not just brilliant people. They may be brilliant people, but they realize that there's no math involved. That changing from one to the other is super, super easy. And we're going to get to that today because we're going to need that skill in order to do one of the things on your homework. Okay? What we know is that it's always based on tens. 10 times 10 is 100. Times 10 is 1,000. You see the pattern here with the numbers. Okay? When I tell students that they have to memorize the stuff on the board, they go, oh, no way, that's way too hard. Okay, if you can do the metric dance, you can do that last one. Let's try that again. Show me milli. Centa. Deci. Meter. Hectometer. Hectometer. Yeah. That way. Kilometer. That way. Decameter. That way, right? That's the width of the room. So now we have an image in our head, so that's easy to come up with. As far as the numbers, well, you see a pattern with the numbers. They all have ones and zeros, and what do we do with the decimal? Move it over to the left. One place to the left, I get 100. One place to the left, I get a 10. One place to the left, I get a 0.1. Please don't talk over me. Another place to the left, I have to put a 0 in there, and I get 0.01. And so on. So there's a pattern there. So the only other tricky part is having to actually memorize the prefixes. And those should make some sense to you. Here's that saying you see at the bottom. Let me begin. King Henry died Monday drinking chocolate milk. Each of these colored letters represents the first letter of the prefix. Okay? Kilo, hecta, deca, deca, centa, mil. This isn't always going to be Monday. It's not always going to be meter. It could be liter, or it could be gram. Depends on if we're making that thing bigger or smaller. Now, how many of you knew before this class had memorized that kilo means 1,000? Okay? You probably even heard people say, well, yeah, I'm going to make 30K this year. That means 30,000. Head up, please. Okay? Hecto, that's pretty easy to remember. H for hecto, H for 100. Okay? It's when we get to these two that people get a little confused. Deca. That sounds like the beginning of a word I know you know, which is? Decade. Very good. Decade is how many years? 10. And that's all that means. So when I put deca in front of something, a deca cookie, that means 10 cookies. Or a cookie that's 10 times as big as a regular cookie. Okay? So all of these make it bigger. These make it smaller. Desa. Okay? All the ones that make it smaller, notice that they end in an I. Desa, centa, milla, all end in an I. They make it smaller. To decimate means to totally destroy. Maybe break into little pieces. They're breaking the little pieces. It's going to be a tenth as big. Centa, like a cent of penny. Okay, how many pennies to $1? 100. How many of these to one of these? 100. Okay, how many of these to one of these? 1,000. And you know the answer is always going to be 1, 10, 100, 1,000. It's going to have those same digits in it. So most of you already knew that milla was 1/1,000. So we take this, we break it into 1,000 pieces. That's how big each piece is. How many are comfortable with this and think that they could reproduce this from memory right now if they had to for a test tomorrow? Yeah, I hope I'll see every hand tomorrow because eventually you will have a quiz on this and you'll have to do just that. Recreate that entire thing and use it to solve some problems. Okay? All right. One of the things I'm going to ask you to do is change from one kind of unit to another. We have to do this all the time. And it's tough in building because we're using inches and yards and feet after it. But in the metric system, it's so much easier. I gave you an example earlier. I said 3 7/8. How many feet is that? Well, you have to think about that. Okay? Changing from inches to feet is kind of tricky. It might even require a calculator to move it. If you don't like math, if you're afraid of math, you should love the metric system. Remember, we don't have to deal with fractions. No fractions. Okay? And the math we can all do in our head, just like we did a little bit ago. All you have to be able to do, and I know many of you did this already in Mr. Cron's class, all you have to be able to do is this. Give it a shot. You have to whistle. It doesn't work unless you whistle. There you go. Okay. Now, I'm going to make it twice as complicated for you now. See if you can handle this. Here's the real complicated one. Got that? Okay. All right. Get yourself warmed up because here comes a tricky one. Whoa is right. Pretty impressive, huh? Did that with one finger. You could solve every one of these conversion problems with one finger. In fact, you can do it in your head and you don't even have to whistle. Let me show you what I mean. Play nice with the podcast. Don't wave at the camera. Okay? So you should recognize these in the order that they go. Here they are again, up here. Kilo, hecta, deca, base. What goes in base? Meter. Desa, centa, and milla. It's the same thing, okay? We're going to use this number line to change. No, not that kind. We're going to use this number line to change from one type of units to another. Maybe I've given you 165 millimeters, but I don't want millimeters, I want it in meters. I want you to put that into meters. So, I know you already know the answer, but I'm going to show the other people how to go about doing this. It's 3 simple steps, and you don't have to write this down, just learn it, okay? I'm going to do an example, then I'll let you guys do some examples. 165 millimeters. First thing I'm supposed to do is have this memorized and write it out. Then figure out where I'm starting. Where are my starting units? Well, I'm starting with millimeters. What are my ending units? Well, I'm ending with meters. So I mark these up here. I'm starting with millimeters, and I'm going to go to meters. You said that was in the middle. You were right. That's the base. Step 3, find the decimal on the number to be converted. Where is the decimal? After the 5. There's no decimal written. It's always at the end of the number. And then I'm going to figure out how many jumps are necessary to go from here to here. There are 1, 2, 3 jumps. 3 jumps to the left. Normally your left and your right. Okay, so I do the same thing on my number now. Same thing on my number. 1, 2, 3 jumps to the left. There's my number. So my answer is 0.165. Got it? How many think they understand the system? Great. Okay? And you can do that in your head without even having to draw this once you get comfortable. If you can visualize this in your head, you can figure out how many jumps it is and do it all without writing anything down. Okay? Alright, so now I'd like some of you to come up and work through a few examples so we all see how this is done. Come on up. My board, by the way, guys, is different from a lot of the other teachers, all the other teachers actually. This is a smart board, it's not a Promethean. You don't have to use their little special pin. In fact, you want to write in green, pick up the green pin, and you can write with your fingertips. Okay? You want to write in red, you pick up the red pin. Or you can use the pin if you like. The other thing that's different, though, is you can't lean on it with your elbow and then write. See what happened there? Okay? You have to just touch with either one point, your fingertip or the pin. So go ahead and show me where we're starting on that line. The first one at the top. Oh, sorry. Well, it'll be a challenge, but you can reach that. Are you right-handed? Yeah. Listen, yeah, I'll leave the last one for you. Come on up. Yeah. You were volunteering. Okay, Brianna. So, we're starting with what units? Millimeters. And we're trying to get to, so circle both of those on the line. And now show me the jumps on the line. There we go. There we go. Okay, so she made 6 jumps to the left. Now she does the same thing on the numbers. The decimal is at the end. Don't worry about it. So you see, 1,276,515 millimeters. You don't know how to whistle, do you? I can't do that thing, but I can whistle more. That's a lot of millimeters, and it adds up to over. Okay, we're done with the whistling. That adds up to over a kilometer on that one. Next example. We'll save you for the one that's wrong. Come on up. 7.8 meters to decimeters. Oh, you're going to erase her answer too? Totally disty. Going from? Yeah, to? Is that right? Is it Dessa or Deca? It's Dessa. Deca would be what? VA. Or in Mr. John's class, VK. Is that right? Okay. Next person. Come on. Need more ladies volunteering. Alright, I'm going to pick on people now. Brianna. Come on up. You. Tree, come on up. Come on up, I'll walk right through it. You will after you're done? Okay. What's the number you have to change? What's the number you have to change? How are we on? What is the units that that's in? Hectometer. Show me hecto up on the number line. Point to it. There you go, right there. Why don't you pick up one of those pins? There you go. So, circle hecto. Where are we going to? What are we trying to change it into? Meters. Where is that? On the number line. Which one? Right, circle base. So, we're going from hecto to meters. Show me the jumps on the number line. Little jumps. Yeah. 1, 2 jumps to the right. Now on the number, show me where the decimal is right now. So where is it always going to be if there isn't one written? The end. Right there. So if you're going to make 2 jumps to the right, what must you add? Too much talking going on out there. What must you add? You have to jump. You got to jump over something. Otherwise, you just look silly. So what do you have to put there? You have to put some nothings there. You know what nothings are called? What are nothings called? Zeros. Put a couple nothings there. No. On the number. Put a couple nothings there. Yeah, be nice now. Now show me the 2 jumps to the right. And now write your new number. What's it going to be? Write it out. Where's the decimal now? No? That's here. Be nice, guys. You didn't volunteer. So.
You didn't cheat.
I know.
0.
Zero.
There you go, people.
You gotta put the eraser. You guys are mean. It's hard because too much pressure, right? Who can tell me what we call those zeros we have to put in there? Huh? Placeholders is right. Those are placeholders, okay? We have to put them in there. If we're going to do the jump, there has to be something to jump around. All right, I think Sedona just volunteered. Yeah, you did. They were mean to you. Show me where we're starting. Starting at on the line. Yeah, all of those. There you go. And going to circle center. That's because it's at the very top. Don't worry about it. Just leave it. Just leave it. That's fine. It's because you're at the very top. You gotta put the erase back. Yeah. Okay. So now, where's the decimal? Okay. Show me what direction you're gonna make your jump. To the left. One jump. Now do it on the number. On the number. Do it on the number so we can see. Okay. You didn't actually show me the jump. You just wrote the decimal on the number. There we go, thank you. See, I have to see this stuff. Is that right? Okay. Hey guys, let me just explain to you, there's a lot of chatter going on, and every time you do that, I just stop and wait, which means there'll be less time for me to explain the homework to you, less time for you to work on it here in class. I just don't like talking over other people. When someone's up here working, you need to be quiet. Okay, millimeters to centimeters and centimeters to millimeters, that's mainly what you're going to do in here, a lot of that. You need to be able to do that. Next example, last example. Come on up. Starting at? Yep. Good. Going two. Good. And a message. I know you're right-handed, right? Can't you use your right hand? So the answer is, does that sound right? Is that right? Diana?
Oh, wait, no.
Which way did you do the jump on the line? Yeah, so it should be. Okay, and that should make sense if you think about this for a moment, guys. That's good. That less than a centimeter. This is a centimeter, right? And that's less than a centimeter. So like that. How could that possibly be 3 of these? There's no way. That wouldn't make sense. So you know that you moved the decimal in the wrong direction. Okay, here's what I want you to do. Get out your planner, open it up. You might get one? You're still going back? Get your planner and open it up to, I think, page 135, 137, something like that. There's a ruler on the edge. Find that page. 137? Yeah, okay, yes. Right. Okay, this is again one of those examples where I'm going to sit here and wait for you to stop talking before I explain what you need to know. Yes, this is homework, and this will take you considerably more time to do than last night's homework. Not because it's harder, just because it takes time. You're going to be doing a lot of measurements. And it's not the kind of thing where you need a lot of brain power for it. I mean, you can be watching TV when you're working on these, or watching my podcast again. You have nothing better to do. But it does take some time to do. Perimeter is defined as, I would say the area. I would say the distance around the outside of an object. Area is something different. Okay? So you're going to measure the distance around the outside of all these different shapes. Now, obviously, some of these you don't need to measure every side. If you look at this example, here, this dimension, this one, and this one are all different. So you have to measure all 4 of them. This one, however, you have to measure how many sides? 1, 2, 3. Because you know this one's going to be the same as this, and this is going to be the same as that. So keep that in mind, and it'll save you some work. Now, I pointed out in your planner where you have a ruler. I'm only doing that not because I expect you to use that ruler, but because I don't want anyone coming back tomorrow and saying, I didn't have a metric ruler, I couldn't do it. You have one in your planner. Is it easy to use for this? No. You probably have to tear it out to use it. And then you probably would lose it and you wouldn't have it for the next one. But if you've got a smaller ruler, one about this size, if you've got a protractor, a lot of them have a metric ruler on it. Now let me ask you, are you looking at the metric side of this ruler? No. How do you know? Because it says inches in big letters. Yeah, it also goes up to 12. On a metric ruler, it goes up to 30, 32, depends on how much they marked on there. Okay, your little guy goes up to 15. So each of these things, 1 through 15, are what units? Centimeters. Centimeters. The little tiny lines are millimeters. Again, if this is boring you, you're free to go ahead and start measuring, but I'm pointing this out because a lot of people don't get it. Look at this ruler here. If I measured an object and it came right up to this point here, what is that measurement? Yes. You said 4.4, you're right. 4.4 what? Centimeters. Okay? Because we know all the big ones are centimeters and the little lines are millimeters. So every little line is a 0.1. 4, 0.1, 2, 3, 4.4. Now, that may seem obvious to most of you, but I have students who get really confused. They see on this worksheet that I'm asking you to give me 2 answers for each shape. Can you see that? Please notice that the answers go above the shape, not below. And they measure the shape and they add up all the numbers and they get their answer in centimeters. Maybe they found out it's 4.4 centimeters. And then they have to do millimeters and they go back and they measure it all over again. Not necessary. Or they go, oh, okay, I know this is in millimeters, so now I have to count the millimeters. 1, 2, 3, 4, and they start counting all the millimeters, all the little lines. Not necessary, okay? This is exactly what we were just doing. You figured it out in centimeters, now we need the answer in millimeters. To go from centimeters to millimeters, it's going to require one jump to the right. So the 4.4 becomes 44. Okay? If you look on the back of this assignment, there's a whole bunch more shapes, but it's going to take you a while. Look at the last 4. I'm asking for your answer in millimeters. That doesn't mean you have to measure in millimeters. Let's say you find out that A is 6.7 centimeters. What would be your answer then? 67. You can change it into millimeters. Okay? So you should be able to do that throughout. I want the answer in millimeters for that last 4. Okay? It says so right on. The others, a lot of them, are giving you both. My other advice to you, because people forget, is that when you measure sides, that you actually put, your measurement right on the shape. You write them on there, because if you don't, people forget and they leave something off. You need to be precise. Go right from the corner to the corner, and then from there to there, and so on. When you're adding up your decimals, you need to make sure you line up all the decimals in a row. Again, I'm assuming you know this, but gotta make sure. Okay, so you can start work on this now. See how far you can get.